For decades, configuring a network meant an engineer typing commands directly into one device at a time, precise, manual, and entirely dependent on getting every single keystroke right. Do that across hundreds of switches and routers for years, and small mistakes accumulate quietly. One forgotten device, one mistyped rule, until nobody is quite sure what state the network is actually in. Intent-based networking starts from a different question entirely. Instead of asking how do I configure this, what if you just stated the outcome you want? Something like guest Wi-Fi traffic must stay isolated from the corporate network at all times. One clear sentence stated once in plain language. Behind that sentence sits a live network model, a constantly refreshed picture of every device, every link, and exactly how they're wired together right now. An intent engine combines the two, your stated goal and the network's actual current shape, and works out everything else on its own. It computes the real configuration every device would need, quietly checks that computation is actually safe, and only then pushes it out to every affected device consistently. And it never really stops. The engine keeps watching forever to make sure the network still matches what you asked for. Let's follow one stated goal all the way to a self-configuring network in slow motion. Take one the old way. An engineer needs guest Wi-Fi kept separate from the corporate network, so they log into each affected switch in turn and type the access control rules by hand. It works mostly, until 3 months later a new switch gets added to the guest network and nobody remembers to repeat those exact same manual steps on it. Take two the intent-based way. The same requirement gets expressed once, declaratively. Guest Wi-Fi stays isolated. No device names, no command syntax, just the goal. That statement is handed to the intent engine, which immediately needs to know one more thing. What does the network actually look like right now? It pulls that answer from the live network model. Every device currently deployed, every link currently active, kept continuously up to date rather than assumed from memory. With both the goal and the current topology in hand, the engine computes a concrete configuration. Which VLAN, which firewall rules, which routing entries on which specific devices. That includes the new switch from 3 months in the future automatically. Because the engine reads the current topology every time, it can never simply forget a device the way a person might. Before pushing anything to real hardware, the engine tries the computed configuration against a model of the network, a safety check, catching a conflicting rule before it ever reaches a device. Only a configuration that passes that check gets pushed out for real to every affected device in one coordinated operation instead of one engineer typing at a time. Guest Wi-Fi traffic is now genuinely isolated across every device that touches it, not because a person remembered each one, but because the engine computed each one. Here's the part a manual process can't match. The engine keeps continuously verifying that the live network still matches the stated goal, checking again and again, forever. Weeks later, someone manually edits a rule on one switch directly, accidentally breaking the isolation. Verification catches the mismatch almost immediately. The engine doesn't just alert someone and wait. It recomputes the correct configuration for that one device and pushes the fix automatically, healing the drift on its own. This whole approach is usually called intent-based networking, or IBN, and the key shift is declarative versus imperative. State the desired outcome, not the step-by-step commands to reach it. It depends entirely on that live network model being accurate. An intent engine computing configuration from a stale or wrong picture of the topology will confidently compute the wrong thing. The simulated safety check matters more than it sounds. Real production incidents have come from configuration changes that looked correct in isolation, but conflicted with something already running. The honest trade-off is trust. Handing configuration authority to software means engineers must trust its computed plans, which is exactly why the simulate then verify loop exists: proof before action, then proof after. Instead of typing commands device by device, you state the goal once. An intent engine reads the network's real shape, computes and safely pushes the configuration, then keeps verifying and healing forever. Thanks for watching. Next time a network policy holds steady for months without a single manual command, you'll know an intent engine has been quietly proving it true the whole time. Check out our other videos and follow how it all runs for more. See you in the next one.